Good morning, all. Today, let us see what is crystal physics and the terms associated with the crystal physics and the types of crystal systems. Before getting into the topic, let us see what is the significance of studying crystallography or crystal physics. It is the science that examines crystals which can be found everywhere in nature, from salt to snowflakes to gemstones. So it is quite interesting to know the crystallography has produced so far 28 Nobel Prizes, more than any other scientific field. In the past history or in the past century, crystallography has been a primary source or force in driving major advances, the detailed understanding of materials, synthetic chemistry, and the understanding of basic principles of biological processes, genetics, and has contributed to major advances in the developments of drugs for numerous diseases. The pharmaceutical and biochemical fields rely extensively on crystallographic studies. Proteins and other biological molecules, including viruses, may be crystallized to aid in studying their structure and composition. Many important pharmaceuticals are administered in crystalline form, and detailed descriptions of their crystal structure provide evidence to verify the claim in patients. So it not only extends its applications in pharmaceutical side, but also the study of crystallography extends its applications in feeding cows, animals, etc. So as assignment, I left to you to come with relevancy or significance of crystal structure in our daily life. So here we are classifying solids into two types. One is crystalline and another one is amorphous solids. What are the differences? In crystalline solids, the repeating units are regular. That is, it is a three-dimensional periodic arrangement of atoms. Whereas our amorphous solids are irregular. So we can say in from our daily life we can see the example to crystalline solid, that is our salt, ice, etc. Geometrical shapes, it is solids have a definite geometrical shape, whereas amorphous solids doesn't do not show a definite shape. Crystalline solids have a short melting point, and amorphous solids do not possess a short melting point. Chemical nature, crystalline solids are anisotropic, that is, properties are different in different directions, and amorphous solids are isotropic. Intermolecular forces are equally shared intermolecular forces, and it possesses a long range of ordered molecules. Examples, as I said earlier, diamond, NaCl, etc. For the amorphous solids, glass, waxes, plastic. Let us see some technical terms associated with the crystallography or crystal physics. Lattice. If we place points periodically, then we can call that one as lattice. So it is nothing but a regular and periodic arrangement of points in three-dimensional space. What is basis? It is an atom or group of atoms. Suppose if we take ionic crystal like NaCl, we have Na plus Cl minus ion. So there we will have two types of ions. One is cation and another one is anion. So atoms are group of atoms or ions. That those are called bases. Crystal structure. So over the periodic arrangement of lattice points, if we place our atom or group of atoms or ions, then we will get the crystal structure. It is nothing but the periodic arrangement of atoms in a three-dimensional space. As a formula, like we can say, lattice plus basis is equal to crystal structure. Unit cell. Suppose if we want to check the entire thing of one substance that we are provided, what we will do usually, so we will take a small portion of it and we will analyze its ductility or malleability or compressibility, all those things we will check with a small portion, and then we will extend all the properties to the entire substance that we are provided, right? Similarly, our crystal lattices here, suppose you consider as a cubic lattice, and we are taking only a small block in that, that is a fundamental block. By repetition along the three directions, in crystallography, usually we have a x, y, z directions. So along x directions, if we repeat this fundamental unit, and along y directions, if we repeat the fundamental unit, and by repeating it along the z direction, if we could construct the entire crystal structure, then that we can call it as unit cell. Since our crystal is a periodic arrangement of atoms, so if we repeat this unit cell along the three directions, no property going to vary. So by having this single small unit cell, we can study the entire crystal structure. So as a precise, we can define it is a fundamental building block which by repetition in various directions give entire crystal structure. Lattice parameters. So here we are taking the unit cell, that is lattice, and we are studying the intercepts and interfacial angles or interaxial angles. What are intercepts? The length of the unit cell along x, y, z directions are known as intercepts. So the length of the unit cell along x direction, we usually say it as A, and length of the unit cell along y direction, we usually call it as B, and length along z direction is C. So these A, B, C lengths are known as intercepts. What are interaxial angles? So we have three axes, and in between two axes we have angle subtended by the unit cell. So in between angle x and y we have x and y axis we have an angle alpha, and y and z axis we have angle gamma, and z and x axis we have angle beta. So these alpha, beta, gamma are interaxial angles. So altogether the intercepts ABC and alpha, beta, gamma are known as lattice parameters. Before going into the crystal system, first let us see what is primitive and non-primitive. So, primitive I can define like if the unit cell consists of only one type of atom, then that comes under the category of primitive cell. So here this is a primitive cell. Why I am calling this as a primitive cell is simple cubic lattice I am calling as primitive cell. Why I am calling this as primitive? It contains only corner atoms. So it is a cubic lattice, simple cubic lattice. Simple cubic lattice means it has 8 corners. So atoms are arranged in 8 corners. Atoms persist in 8 corners. So this is a simple cubic lattice which contains only one kind of atom, that is corner atom. So this we can call it as primitive cell. So if you see all other remaining types like a body-centered, side-centered or base-centered or face-centered, we can say those all come under the category of non-primitive because it contains corner as well as other kind of atoms, body-centered atom or base-centered atom. In addition to corner atom, these lattices contain some other kind of atoms too. So those all come under non-primitive. So only one kind of atom this contains simple cubic lattice. So this is a primitive lattice. The crystals are based on lattice parameters. divided into 7 categories, that is we call usually as crystal systems. So based on intercepts ABC and alpha, beta, gamma, the crystal systems can be categorized into 7 types. What are the 7 crystal systems are? Cubic, tetragonal, orthorhombic, monoclinic, triclinic, triangle, hexagonal. So cubic. So simply we can store in our memory like with the mnemonic for all these 7 crystal systems. So cute, Tom, the first letter T, O, M, Tom. The first word is cute, Tom, triggers and tries Hercules. Usually we people come across with the Tom and Jerry episode, right? So there we are taking, but instead of Jerry, here we are putting Hercules. So cute Tom triggers and tries Hercules. It is not compulsory that you need to memorize this mnemonic. As per convenience, you can make it. For simply to keep it in our brain, yeah, I'm just saying this. So here how we can remember this? Just if we group this 1 and 6, that is cubic and triagonal, all the intercepts are equal. That is A equal to B equal to C. And tetragonal and hexagonal we can match together and we can keep in our memory like A is equal to B but not equal to C. For the all other remaining 3 systems, no intercept is equal. That is A not equal to B not equal to C. If we are coming to the side of interaxial angles, then our first 3 systems alpha, beta, gamma all are equal to 90 degree. So monoclinic, we can simply memorize that mono means single. So single interaxial angle is not equal to 90 degree. So other two interaxial angles are equal to 90 degree. Triclinic, so tri means 3, all are not equal to 90 degree. All the interaxial angles alpha, beta, gamma not equal to 90 degree. So if we come to the trigonal system, then that is all are not equal to 90 degree, but one more constant we here is all the angles are less than 120 degree. Hexagonal system alpha beta are 90 degree and gamma is equal to 120 degree. So axial length we can combine cubic and triagonal, we can easily memorize all the intercepts are equal, and tetragonal and hexagonal we can combine and we can say two intercepts are equal and last one is not equal, and for all the remaining systems all the intercepts are not equal. Interaxial angles, so first three systems have the same interaxial angle that is equal to 90 degree. All alpha beta gamma are equal to 90 degree. Mono means only one angle is not equal to 90 degree. Tri means all the three are not equal to 90 degree. Triangle, all the three are not equal to 90, but all the three are less than 120 degree. Hexagonal, alpha and beta are equal to 90 degree, but gamma is equal to 120 degree. So based on these A, B, Z and alpha, beta, gamma, we can plot uh, system diagrams. Next, coming to the case of here itself, in the slide itself, we can